Thank you. So thanks very much for coming. We have some stickers here. I'll ask that after the talk.
Lots of
Please
stickers.
Come. Yeah, lots of stickers. Please come get some stickers. I have a quick question before I start, which is, how many people here have heard the term lunar punk used? Okay, and how many have heard of DarkFi? Okay, so there seems to be some kind of overlap, which is good, because I'm going to talk about both things. I'm going to start off speaking about our macro thesis, basically identifying what we see as some feedback loops that are driving value and users into anonymous systems and away from transparent systems. So this is a bit like our bull thesis for anonymity, but it's also fundamental to the kind of lunar punk meme space as being the means by which the lunar punk future kind of emerges. Then I will briefly speak about some more kind of deep philosophical questions, such as, you know, where are we going with this? Why are we exiting from the surveillance apparatus? What do we hope to gain from this this process of exit? And then in the latter half of the talk, I will give a presentation on DarkFi specifically. I will discuss our alpha testnet and explain how we achieve generalizable programmability on DarkFi. So it's 3 parts, and there's kind of a bit on more economics, then it will go into philosophy briefly, and finally, I hope to spend the second half talking about tech. There will be a more technical presentation tomorrow at 10:30 from Amir Taki, which will be on the math aspect. I will explain slightly more as we go on, but I highly recommend his talk for a more technical overview of what we're building. So this is a feedback loop between surveillance and anonymity. Anyone who has worked in cryptography is familiar with this dynamic. So effectively, the progress of cryptography is a kind of cat and mouse game in which cryptography continuously has to update its mechanisms in order to adapt to the increasing all-pervasiveness and increasing sophistication of surveillance techniques. So there is a feedback loop whereby the more sophisticated surveillance becomes, the more anonymous techniques must advance in order to bypass it. So this feedback implies that both surveillance techniques and anonymous techniques are going to escalate. We're going to see a mutual co-development of these 2 distinct worlds. How does this dynamic apply to a crypto context? I think these 2 worlds function as kind of attractors that warp the development of crypto, that bend it in certain directions. So in the surveillance space, we have the development of RegFi. RegFi is our term for crypto that has adapted toward the increasingly stringent requirements of the surveillance state. So it's kind of like the anti-crypto. It's the death of crypto. It's crypto as it merges with surveillance. On the other side then, we have the side of crypto which is anonymous, anti-fragile, parallel infrastructure that we call DarkFi. So this is anonymous crypto that will be vindicated as the true spirit of crypto. And, you know, in terms of the underlying forces, surveillance is based on a mechanism of control, whereas anonymity is about freedom and emancipation. So many of you might be familiar with the anti-fragility thesis presented by Nikola Tayeb. So this is a diagram of a fragile and an anti-fragile system. So you see they've got this nice positive and negative convexity. The graph says concave, but you know you can call it positive and negative convexity. So what that means is a fragile system is something that breaks when under pressure. An anti-fragile system is something that absorbs shocks and becomes stronger. And we can see here, it's not this effect is not linear. It's actually closer to some kind of exponential function. So this is a linear relation. We can imagine, say in the case of something like a crypto wars, which is like the era that we're in at the moment, especially in the wake of Tornado Cash, but really it's been going on for decades. And it's not even the first crypto war. So we've seen this situation of crypto wars spiraling, unfolding in time. And as the crypto wars unfold in time, we can imagine that anonymous systems accrue more users. So this imagines there's a linear relationship. As the crypto wars unfold in time, the amount of users that anonymous systems attract also grows in step with that. However, as we saw from the anti-fragility illustration from before, it's not a linear relationship. There's something else that's happening that gives that convexity. So we're looking for some other dynamic that is really fueling the capturing of value and users into anonymous systems. So this quote is something a little bit closer to that dynamic that we're really looking for. This is Jay Stark. Who here has heard of Jay Stark? Wow. Okay, so more people have heard of Lunarpunk than heard of Jay Stark. Jay Stark, totally. Okay, so Jay Stark, he's a German Kurdish man who created the FGC9, which was like a fully DIY gun that you could build using simple materials that are readily available. So he really took the concept of 3D printing, 3D printed guns, and completed it by making it something that was like, highly simple and with consumer materials. So Jay Stark, he was murdered by the state about 2 years ago now. But this is a quote from him. He says, "If something unfortunate happens to one individual, another individual will take his place. It's a hydra you cannot completely kill. You cut off one head, another pops up. We are impossible to stop." Woo! So that's a beautiful quote. Well done, Jay Stark. Which gets a little bit closer to this dynamic that we're looking for. So, the dynamic could be thought about in the context of an insurrection, where insurrection happens, a revolutionary is killed in action, 20 more revolutionaries come to take her place. So this is the kind of anti-fragility and the convexity that we're looking for. You may be, or you probably are familiar with Metcalfe's law. Was proposed as a way of valuing networks. It says that the value of a network is proportional to the number of users. It's actually equal to the number of users squared. So we propose a version of this. We call it Jay Stark's law, which is inspired by the ethics of free software. So free software puts into positive feedback the notion of user empowerment and developer empowerment. So user empowerment and developer empowerment are positively correlated to each other in the free software paradigm. So we adapt this value judgment made by free software into this Jay Stark's law, which says user empowerment is positively correlated with system anti-fragility. So the more empowered your user base, the more anti-fragile your network becomes. So it's using this conjecture, this proposed mechanism, that we're able to achieve that nice positive convexity that we're looking for. So let's apply this reasoning to a real-life scenario. Let's imagine that there's some moment of escalation in the war against crypto. Say, for example, that self-custody is banned. Like, which could happen, kind of is happening in some places. So self-custody is banned. We have, it's not this linear situation. We have a rapid, sudden descent into fragility. So we have users fleeing the networks en masse. As they're on a transparent system, users are potentially liable for their activity on that system. The crypto wars escalation leads to this mass flight, this descent into fragility, and this rapidly descending user empowerment and system anti-fragility feedback. On the other hand, in an anonymous system, this dynamic is reversed. So we see that as hostile powers try to restrict anonymous systems, they fall into something that we call the regulation trap, which is the harder they try to prohibit access to these systems and to prohibit people from using them, the more the utility of those systems is justified. So actually, the whole effort of trying to restrict access to these systems is, in a strange, paradoxical way, affording more power over to those systems. So as we can see, in the case of a crackdown on an anonymous system, we actually see a rising political consciousness within the community. We see a rallying of individuals around that project, which leads to growth in users and eventually accumulates in this final stage in the convexity curve, which is, actually suddenly there's economic advantages to moving over to those anonymous systems. And an example of this was, I'm sure many of you were following what happened with Tornado Cash. What was very interesting was, instead of Tornado Cash being deleted by the OFAC sanction, it actually was more like a point of radicalization, where you had many people in the crypto community speaking out against surveillance and draconian regulation for the first time, and the Telegram group of Tornado Cash suddenly becoming more active. People were redeploying the contracts on IPFS, etc. So it had the opposite effect. Okay, so that's that explains a little bit the kind of economic theory behind Lunarpunk and why anonymous networks are going to grow in value in users. I'm now going to go into a brief section on the philosophical aspect. Okay, so as we can see, I'll just go back briefly. There are feedback loops intrinsic to this process. We mentioned some of them. But really this positive convexity, this anti-fragility, is more like an open spiral. So we're spiraling outward, we're engineering a kind of agorist exit from the surveillance state. The question becomes, where are we exiting to? And why are we exiting? What is this new world, this dark forest that we've emerged to? Dark forest is a term that's used by Lunarpunks. Generally means an anonymous world protected by encryption that has decoupled from the surveillance state. So we found ourselves here inside the dark forest. Why have we come here? So we know, for example, that the dark forest is protective. The example that I always like to give is a historical one, which relates to the conflict between Ireland and England, where the first time England tried to invade Ireland, that was failed. It was ultimately failed because at the time Ireland was covered in forests, and those forests were the basis for widespread, decentralized, invisible guerrilla resistance. So while the invasion was initially effective, traces of the invasion were entirely erased as the years unfolded. So the efforts were absorbed into the forest by virtue of that amazing decentralized, invisible resistance made possible by the forests. So in order to actually gain a foothold in Ireland, the British forces first had to destroy the forests. And it was only through clearing of the forests that they were actually able to fully colonize Ireland. So we know that forests can protect divergent groups, you know, that they can incubate and protect communities, but what kind of communities do we want to build in there, and what are we trying to protect? So Nietzsche has a really nice a discussion on morality, where he says that what he calls the morality of the master, he also aligns it to the state, basically imposes a morality on people and says, you know, this is good and evil, that's what you have to accept. The problem is when people try to resist against something like the state or some other monopoly, they do a simple inversion where they say, okay, that's what the master says, I'm going to say the opposite thing, and that's my values. So you have this inversion, this negative copy. But the problem is that if you're in this simple inverted state, you haven't properly escaped the morality imposed on you by the master. You're still within the dialectic. So you have to transcend that morality. And the way that Nietzsche says that we have to transcend it, he says we must become what he calls philosophers of the future. Philosophers of the future create new values beyond the state. So they're in the creation of new values, and he proposes something which he calls genealogy, which is about being very aware and analysing what are the different forces and what are the different morals, where do they come from, what are their origins, and from there constructing something genuinely new and outside of this morality that's imposed by the state, and also outside the inverted morality which comes from the people, which is simply a copy, but an inverted copy of the state. So Öcalan, he says something similar. He says that the society has been enslaved by the state, and it's lost its own morals and politics. It just has a false morality which is imposed by the state. So he says society needs to regenerate this moral and political fabric. And he offers some practical ways of doing that. We list a few of them here. We have Hui Na Zin, self-knowledge, but also know thyself, which is like this process of reflecting on your own origins and the myths that have formed you, and that kind of inward reflection at the society level. Hui Parastin, which is self-defense, that's a big part of escaping the kind of seizure of morality and politics by the state. And finally, the notion of Huibun, which means autonomy or self-being or self-becoming, which this is how we achieve something which is not simply like an anti-state, you know, which anti-state is still in this negative inversion of being an inverted copy of what the state is. So this is something closer. This is why we talk about lunar punk as a non-state. It's something that's genuinely exterior to the status paradigm that has been imposed. Okay, so we have this beautiful image. This brings me to one of my favorite patterns in science fiction. So one of my favorite patterns that happens across science fiction books and novels, etc., is the moment in which a society discovers some kind of alien life or a new kind of technology. An example would be like in The Expanse when they discover the ring. And what's interesting about these moments is that it's a transformative contact. So it's a moment of contact with something so radically exterior and so alien that it completely reconfigures the horizons of the possible. So it's a contact and a transformation that changes the space of potentiality forever. So I'm coming now to the technical part of the speech. I believe we're at a similar moment in relation to anonymous engineering. So I call it here xenotechnics, that means alien techniques, because it's something so radically exterior and so novel that it will permanently change the horizons of the possible. And it's really a contact with this kind of alien force. And if you're interested in this concept, which I will briefly touch on but not go deep into, I can encourage you to attend Amir's talk tomorrow at 10:30, which will give the actual math examples of what I'm about to talk about. So DarkFi, here's a definition, is an L1 for anonymous engineering. Anonymous engineering, I touched on it briefly. Effectively, what we mean is a new kind of engineering which is based off of engineering anonymous schemas, and we will give some examples. And so DarkFi is an L1 to enable this kind of anonymous engineering, which means we expose an interface by which developers can integrate cryptographic techniques into their programs that allow them to construct these anonymous schemas. So we can give the example of ZK, but it's not just ZK. There's many other techniques that can be integrated as part of an anonymous schema, including multi-party computation, homomorphic encryption, and many other exotic crypto techniques that have emerged in the past few years. So DarkFi is really trying to provide a way, a simple way for developers to integrate all these tools and to make applications that dramatically extend the design space that we currently have in projects like, or an ecosystem such as Ethereum. And that's very much our vision is, we're very inspired by the frictionlessness and the level of creative innovation that's been made possible by places like Ethereum and, spaces like DeFi and the other kinds of innovations that have come out of that. So we want to extend that design space. We want to push it to its limits by integrating anonymity as part of that. Overview of where we're at currently. We have our first testnet, which is live and operational. You can download the software and run it and join the testnet, play around. We're using an anonymous proof of stake called Ouroboros Crypsinus, which is very interesting. It's important to note that it's quite different to proof of stake as we have it on Ethereum, where, in Ethereum there's a concept of slashing. In DarkFi there is no slashing. It's kind of conceptually like a fusion between proof of work and proof of stake, in that nodes participate in this anonymous leader selection by creating a local proof, and they do that by running a lottery local on their computers, and they have stake as a variable in that lottery process, which increases the probability of them winning the lottery. So if they win this lottery and they go through these steps, this algorithm, then they can produce a proof that allows them to create a block. So this is an anonymous leader selection protocol, which is MIV resistant and censorship proof. So alongside this blockchain, we have a general purpose smart contract infrastructure. I'm going to, in the next slides, discuss a little bit what that is and how that works and how we achieve general programmability on DarkFi. We also have an app-driven approach. So there are other kind of ZK L1s that exist at the moment. They have a kind of backwards approach to engineering, where they are starting by engineering abstractions, and then they're trying to engineer apps from there, but we can see that they're creating complexity traps for themselves. So we've taken the opposite approach, where we're actually building apps, and we're letting those apps dictate decisions on our smart contract architecture, and also to inform the design choices we make in terms of abstraction. So the apps that we have currently working are, we have an anonymous DAO that's working on the testnet. You can create a DAO on the testnet now if you download the testnet. We also have swaps. It's called here a non-OTC. That's atomic swaps. We have anonymous transactions, anonymous staking with the Ouroboros Cryptonos, and we also have anonymous coordination tooling, such as an IRC, which is highly anonymous. I will discuss that a little bit later. So I will briefly explain DarkFi's general programmability. So we have on the network, all nodes are provers and verifiers, all full nodes. Provers create the anonymous transaction, which is like they load locally, they interact with these ZK proofs, and they put their secret values into them, but those secret values are never revealed on the network. So the prover does that locally. They then broadcast that transaction, which is like, with these anonymized or anonymous inputs to the network, where they are picked up by these verifiers who verify according to the particular contract. They verify the various crypto and the signatures, and then they transition the blockchain to the next state. So transactions on DarkFi contain multiple function call data. So we see here t is equal to C1 to n. We can have an arbitrary number of function calls data in a transaction. Transactions are also atomic, so we can have chains of logic where if one function call fails, the rest of the transaction will fail. And this is how we achieve advanced anonymous apps, such as protocol-owned liquidity, which we will look at in the next couple slides. So this call data is arbitrary data, which is defined by whatever contract is being used. Depends on the contract. So if that's like for money or for the DAO, etc., that will determine what the call data is, and it can contain proofs and signatures, commitments, etc. So to achieve this, we have like different layers. We have a ZK assembly language and virtual machine, which is using Halo 2. So that is how we achieve the zero-knowledge proofs. And there's a pipeline where we use this very, very simple assembly language, and that's compiled down to bytecode, which is run on the VM. The assembly language, I highly recommend you check it out. It's very beautiful and very simple. I have a newfound appreciation for it since today attending a workshop with other ZK languages and being very disturbed by the complexity of the languages. ZKS, we've kept it intentionally simple, intentionally like low level for now, such that when you read it, you can actually understand what it's doing. Which I think is really important when it comes to ZK proofs. Anyway, that's a tangent. So we combine this, these ZK proofs with, we also have a WASM runtime. So when we talk about smart contracts on DarkFi, they are using WASM. And we write them in Rust, but WASM is such that you could write them in other languages. Those WASM contracts have access to an SDK, which includes all these different primitives that allow you to engineer anonymous applications. So, signatures, elliptic curves, commitments. We will extend this gradually. We're on alpha testnet now, and we've kept things intentionally simple, intentionally manageable. But the idea is to gradually extend so that developers can build increasingly sophisticated applications. So currently on DarkFi, we have two main contracts on the WASM. So we have the money and the DAO. Inside money, we have these function calls, which allow us to do the swaps and also the staking. So you can see money transfer. That is, if you guys are familiar with the sapling payment scheme, we will talk about in the next slide how that works in the context of DarkFi. But Sapling, it's an anonymous schema that was invented by Zcash, and we use that as well in DarkFi to do anonymous transactions. And actually, in other apps, we use this money transfer as well in this chaining of function calls that we do in the application design. Then we have this OTC swap, which is, we create an atomic swap between two parties. And then we have this stake and unstaked functionality, which is used for the Ouroboros Crypsinus anonymous staking. So yeah, this is our, one of our big achievements as well, that we created this anonymous DAO, which is the first anonymous DAO, and it's working on our testnet, so that's pretty cool. So you have DAO Mint. You basically create a new DAO with various constraints that you set. So you decide on things like what is the quorum, what is the proposer limit, like how many tokens do you need to make a proposal. And so there's we will actually look more deeply, but there's several constraints. You create a DAO, you make a proposal to the DAO, and you vote on a proposal, and finally DAO exec is an operation which transfers money from the DAO treasury to an address specified in a proposal. And so it's essentially a form of protocol-owned liquidity that is conditional, and that can allow for advanced on-chain applications. So this is a simple kind of diagram to explain Sapling as it works in the DarkFi context. So on the right, we have the proofs. This is like a simplified version. So we have a mint and a burn proof. Mint is whenever we make a transaction, we output a mint proof, and we burn. We input a burn and we output a mint. So we can see that here it says, Alice wants to send tokens. So the way she does that is she first produces this burn proof. She burns those tokens and then mints these other tokens to Bob. So that's unlinkable and anonymous. Here we have the schema. This is like a kind of simplified version, just to get an intuition for how that works. So in a mint proof, we create a random serial number. Then we create C, which is a hash of a serial number, and any number of attributes. So C is actually our coin, where we can put inside different information, like the token ID, the value of the token, and then we broadcast C, we make it public, and we transition the state. Then from the burn side, we reveal something called a nullifier, which is our double spend protection. And the way that the protocol is designed, as soon as you reveal that, the coin is spent, and you cannot. It protects against double spend. That's because it's deterministically generated from the private key and a serial number that is created in the mint step. So then we do something called a Merkle inclusion proof, which basically just proves that that this is the correct coin and it exists in the state. So that's the burn proof. This then, so we use those mint and burn proofs also within a DAO application, but we have the other proofs as well. So like we've got vote, propose, etc. And here's the diagram, which it doesn't show the mint step. This is showing voting, which is number 1, and 2 is the DAO exec. So on number 1, we can see that someone has created a proposal. That proposal, checks various constraints that are set by the DAO. the proposer limit, which basically says, do you have enough tokens to make this proposal? The quorum, which says how much tokens need to be committed to this in order for it to be considered valid. And then the approval ratio. What is the ratio of yes to no votes in order for this proposal to pass? So this is all set when you create the DAO. So the participants vote on this anonymously, and if those votes satisfy the constraints of the DAO, then the operation can be executed. Similarly, I didn't mention in the previous slide, or I didn't mention here, that we are also hiding the amounts in a transaction using Pedersen commitments, and the same is true here, that that all the amounts are hidden and everything is anonymous. Aside from, you can tell when if I recall correctly, when a vote happens, you can tell that voting is happening on a proposal, but you cannot tell what the vote is or what the proposal is. You can just tell that a vote is happening on a proposal in terms of the blockchain, because we reveal the function calls. Okay, so to back up a bit, DarkFi also has its own peer-to-peer network. This is designed to be highly modular, so it can run over Tor, it can run over NIM. This means we're the only project that is working at, that is seriously considering network level anonymity. We have these Tor and NIM integrations already working, so that's important. On this peer-to-peer network, we have a fully anonymous IRC. I mentioned that the peer-to-peer network is highly modular. It's very easy to deploy apps on it. So this is one such app. It's IRC, but that we've integrated onto the peer-to-peer network. We've also added some really nice anonymity features. So we have encrypted channels, we have encrypted DMs, and we also have a really nice ability to change your nick as many times as you want. So the IRC has no concept of identity. You can appear as anyone, it's completely invisible on the network and on the client, it's completely unlinkable, the IDs. So there's no identity. And we will, as a next step, also release a spam protection, which will include rate limit. We will use rate limit nullifiers for that. So highly encourage you to join our IRC if you're interested in DarkFi. We have dev meetings every Monday at 4 o'clock Central European time. So spin up an IRC daemon and join our chat with WeChat. It's very chill. Okay, so in terms of the timeline, I mentioned that we have kept DarkFi intentionally simple. So with the current architecture that we have, which includes the zero knowledge component and this WASM component, which also integrates the SDK, we can design many interesting applications. So we have already the DAO and the money. We will soon also have stuff like NFTs, and there are many other projects or apps that can be quite simply deployed using this. But we will slowly add more and more features to extend the design space. Like, for example, multi-party computation is an important one. But we're intentionally postponing that because we're simplicity oriented. So we're going step by step. And the current status is we've released this alpha testnet. We're stabilizing it, smoothing it out. And we have to finalize the token. Right now, the proof of stake, it just has, it has a token, but it's like a dummy token. We haven't done any actual token engineering. So the next release will contain the fully fledged Dark token. That will be the testnet beta. Then we will go into an audit phase where we need to audit every aspect of the code base. Depending on how long that takes, we will then deploy mainnet. So the current version of Darkfy is pretty much where we want to be when we release the mainnet, minus the token engineering and minus the audit. And depending on how long the audit takes, we can target mainnet for optimistically end of this year. But maybe the audit will create new work for us that will drag on for longer. So it could be a year from now. But basically, we're very focused on shipping mainnet as quickly as possible. And yes, so if you want more information, check out our website. On there, we have a link to the docs, which will give you instructions on how to install and run the testnet and the IRC, where we have the developer meetings every Monday at 4 o'clock. You can also follow us on Twitter, although it's not that active. You're better off following us on IRC. Similarly, there's our GitHub. Check it out, and happy to answer any questions that you have.
Thank you very much, Rachel. Big round of applause. Now, the deal is we have 10 minutes until the next speaker. The next speaker is very interesting. There is some very interesting stuff down here for people who need a little exercise, walking up and down the steps. You have a question, sir? Okay, if you keep it short, keep it to the point, and Rachel doesn't go into a long answer. Shoot.
Okay, I'll try.
Okay.
Are you concerned at all with the emergence of dark DAOs, like lowering the barrier for kind of committing attacks, right? So when I think of like a dark DAO, I think of the ability for people to anonymously coordinate to launch an attack, right, without revealing, right, that they would like to launch an attack. So you could imagine a governance system being compromised by a minority of token holders, right, because people just kind of keep committing tokens to do the attack, committing tokens until some threshold is reached, right, such that you can achieve quorum, right. You could also think of it, in more traditional terms, right, in terms of validators, right, coordinating to compromise some network, validators of oracles, right. So are there things we can do to mitigate the impact of this, or is this just kind of like the new reality that we live in?
Tough question. You go ahead.
Oh, I have a mic, sorry. Yeah, I agree that, anonymity and privacy, they come with these negative externalities, such as you can imagine, like you said, like interesting anonymous DAOs coordinating to do stuff without this this issue on ETH where they couldn't do that because they would be caught by police and stuff. So yeah, I definitely think that the privacy comes with negative externalities, but I think that the gains for freedom outweigh the cost, the potential cost in terms of risk that comes from things like dark DAOs. So I'm much more concerned about the potential dystopic impact of us totalizing surveillance state that we're heading into than I am concerned about the ability for people to coordinate anonymously to do illegal actions. Sorry, I don't know if that answers.
All right, maybe there's a chance to follow up on the question afterwards. We'd give everybody else a chance to jump down here, grab a very cool sticker if they want. Thank you very much, Rachel.
Thank you.
We have about 5 minutes before the next talk. Thanks a lot.
Nice.